At the end of this video, you should be able to describe the formation of the land, the atmosphere, and the oceans of Earth. Chapter 27, Section 1, Formation of Solid Earth. When Earth first formed, it was very hot. Three sources of energy contributed to the high temperature on the new planet. First, much of the energy was produced when the planetesimals that formed the planet collided with each other. Second, the increasing weight of Earth's outer layers compressed the inner layers, which generated more energy. Third, radioactive materials that emit high-energy particles were very abundant when Earth formed. When surrounding rocks absorbed these particles, the energy of the particles' motion led to higher temperatures. Early solid Earth. Young Earth was hot enough to melt iron, the most common of the existing heavy elements. As Earth developed, denser materials such as molten iron sank to its center, and less dense materials were forced to the outer layers. This process is called differentiation. Differentiation caused Earth to form three distinct layers, as is shown here. At the center is a dense core that is composed mostly of iron and nickel. Around the core is the very thick layer of iron and magnesium-rich rock called the mantle. The outermost layer of Earth is a thin crust of less dense silica-rich rock. Today, processes that shape Earth, such as plate tectonics, are driven by heat transfer and differences in density. Present solid Earth. Eventually, Earth's surface cooled enough for solid rock to form. The solid rock at Earth's surface formed from less dense elements that were pushed towards the surface during differentiation. Earth's surface continued to change as a result of the heat in Earth's interior, as well as through impacts and through interactions with the newly forming atmosphere. Formation of Earth's atmosphere. Like solid Earth, the atmosphere formed because of differentiation. During the original differentiation of Earth, less dense gas molecules such as hydrogen and helium rose to the surface. Thus, the original atmosphere of Earth consisted primarily of hydrogen and helium. Earth's early atmosphere. The high concentrations of hydrogen and helium did not stay with Earth's atmosphere. Earth's gravity is too weak to hold these gases. The sun heated the gases enough so that they escaped Earth's gravity. These gases were probably blown away by the solar wind, which might have been stronger at the time than it is today. Also, Earth's magnetic field, which protects the atmosphere from the solar wind, might not have been fully developed. Outgassing. As Earth's surface continued to form, volcanic eruptions were much more frequent than they are today. The volcanic eruptions released large amounts of gases, mainly water vapor, carbon dioxide, nitrogen, methane, sulfur dioxide, and ammonia, as is shown here. This process, known as outgassing, formed a new atmosphere. The gases released during outgassing interacted with the radiation from the sun. The solar radiation caused the ammonia and some of the water vapor in the atmosphere to break down. Most of the hydrogen that was released during this breakdown escaped into space. Some of the remaining oxygen formed ozone, a molecule that contains 3 oxygen atoms. The ozone collected in the high atmospheric layer around Earth and shielded Earth's surface from the harmful ultraviolet radiation of the sun. Earth's present atmosphere. Organisms that could survive in Earth's early atmosphere developed. Some of these organisms, such as cyanobacteria and early green plants, used carbon dioxide during photosynthesis. Oxygen, a byproduct of photosynthesis, was released. So the amount of oxygen in the atmosphere slowly increased. About 2 billion years ago, the percentage of oxygen in the atmosphere increased rapidly. Since that time, the chemical composition of the atmosphere has been similar to the present composition of the atmosphere, as you can see here. Formation of Earth's oceans. Some scientists think that part of Earth's water may have come from space. Icy bodies, such as comets, collided with Earth. Water from these bodies then became part of Earth's atmosphere. As Earth cooled, water vapor condensed to form rain. This liquid water collected on the surface to form the first oceans. The first ocean was probably made of fresh water. Over millions of years, rainwater fell to Earth and ran over the land, through the rivers, and into the ocean. That rainwater dissolved some of the rocks on the land and carried those dissolved solids into the oceans. As more dissolved rocks were carried to the oceans, the concentration of certain chemicals in the oceans increased. As the water cycled back into the atmosphere through evaporation, some of those chemicals combined to form salts. Over millions of years, water has cycled between the oceans and the atmosphere. Through these processes, the oceans have become increasingly salty. Where shallow ocean water has evaporated completely, the salt precipitates and is left behind. This left behind salt may be harvested for human use, as is shown here. The ocean's effects on the atmosphere. The oceans affect global temperatures in a variety of ways. One way the oceans affect temperature is by dissolving carbon dioxide from the atmosphere. Scientists think that the early oceans also affected Earth's early climate by dissolving carbon dioxide. However, Earth's early atmosphere contained less carbon dioxide than the Earth's atmosphere does today. Thus, Earth's early climate was probably cooler than the global climate is today. At this point, you should be able to describe the formation of the land, the atmosphere, and the oceans of Earth.